Hi, Oleg, or Oleg Shelayev, right? This is the perfectly pronounced name again.
Absolutely. Absolutely. Hi, Adam.
Hi. I forgot to mention the last time that if someone watches your YouTube stream, they can easily recognize you by the glowing, red glowing mic, right?
Oh yeah, yeah. This is a gimmick, right? It's a gaming mic that I got when I was looking for it. This was kind of sort of the best that I had at the shop nearby.
Okay. Is it actually a hot?
No, it's not. It's not hot, but like it has this thing that.
Okay.
And now I'm unmuted and you can't hear me. So there is a very little capacitor button, and I can touch and mute myself in like no time.
Yeah.
Very convenient.
Muting works. The listeners will recognize that because.
Yes.
Perfect.
Oh, look, it's so convenient at all the like online meetings nowadays, right? Because like you have to juggle like a few different apps, and then you have to set up the shortcuts, and then sometimes you never like find them when you need to mute or unmute quickly, and this is just a lifesaver.
So first, you already introduced yourself. So now we can focus on GraalVM exclusively, if you like. It's hard, to start with because GraalVM is one of the unique technologies which does actually everything and everything well. So, but how you would introduce GraalVM to Java developers? What is your official Oleg introduction?
Yes, it's a very interesting project, and in a nutshell, this is a runtime for your applications, right? So this is the virtual machine that you will use to run your applications, and there are several features, so to speak, that distinguish them from your other options. So it's high performance. It is a polyglot virtual machine. It is an embeddable virtual machine. So there are a number of characteristics, but in a nutshell, this is something that it will just power your applications, right? And you would use it to run it. Now, the question becomes not, oh, why should I use GraalVM? Right? Because you already are using some sort of a runtime. Most probably for a Java developer, that is the OpenJDK based JDK that you're using. So the question becomes, why should you prefer GraalVM to something else?
Yeah. Okay. And I was actually, this is hard actually to find, I think, because I had already a chat with Sean Smith, and he told me that the GraalVM without the native compilation, so GraalVM is just compatible with OpenJDK, you can say, right? And with OpenJDK 16 even. So you can just pick GraalVM and replace your OpenJDK without any modification, and your application will run. What I learned is that it is the most performant JVM on the market right now in just, the, how to call it, in JVM mode. So like, the regular JVM operation, right?
Yes. So one of the differences what GraalVM offers you is that it comes with the top tier just-in-time compiler, a different top tier just-in-time compiler, right? So when you run your applications on GraalVM in digit mode, so normal Java applications, you run Java minus jar and they pass to your application. It starts the normal Java hotspot virtual machine, and it runs absolutely in the same way like any other hotspot distribution would run, right? So it locates the classes, it starts loading them, verifying the classes, it starts executing them in the interpreter. But the top tier just-in-time compiler, this is the most optimizing compiler that is in the distribution, is different. This comes from the GraalVM project, and when the VM decides that certain parts of your application need to be compiled again and again and again, right? So because they are getting hot, they're getting more use. It gives the application code to this top tier compiler, and because
what
it's
is the name
very
of the top tier compiler? Is this
in
some
GraalVM?
Yeah.
Right, in GraalVM, it's called the GraalVM compiler.
Oh, I thought this is not a funky name like, I don't know what, dinosaur or leopard or whatever, right?
No, unfortunately not.
This is boring. So you have to invent something. Usually everything has a cool project name.
Yes, and there is a bit of history there, right? So, but like in OpenJDK, the top tier just-in-time compiler is called C2.
C2.
So
okay.
C2 is what you would use by default, right? If you're using, say, an OpenJDK build, and the GraalVM compiler is what you're going to use if you're running the GraalVM builds. And because it's a great compiler, it will eventually optimize your code better, and then you potentially can have significant speedups in running your applications.
Mm-hmm. What is significant?
This is a great question, right? It varies heavily, right? So GraalVM has two distributions that you can use. There is GraalVM Community Edition, which is the open source bits, which are currently available under open source licenses on GitHub. For Java components, we typically try to mirror the original like runtime licenses there, right? So we want to be a good open source project, and we want to be also a sort of an easy replacement for whatever you were using previously. So Java bits are under GPL2 plus ClassPass exception, similar to OpenJDK, right? And then our Ruby components under the same licenses as the Ruby, the like MRI, and the JavaScript as the JavaScript, and so on. And then our code, right? The code that we create, like for example, the Truffle framework, that there is no analogs for that, which is the framework that we use to implement the languages on GraalVM. Those are usually under UPL, which is a very permissive open source license. Mm-hmm. So the team packages those open source components, we build them, we test them thoroughly, and we make that available under the GraalVM Community Edition distribution name, right? Mm-hmm. And it is a little bit faster than OpenJDK if you look at the very large corpus of the benchmarks. Mm-hmm. We know that it's faster, but if you sometimes it's a little bit volatile, mm-hmm. right? So so the performance results may vary, specifically on the code which has been optimized very much to be fast on C2. Like it's already very fast on C2. It's very hard to be better, right? So okay. so there the performance speed up could be not as great, or it could even regress a little bit.
Yeah. On the code what I have to admit is in my projects, and what I refer to my project is project where I was involved, which could be project where we implemented something together, or code review. So I see actually lots of projects. Usually in enterprise, the focus is on simplicity, right? So I don't think lots of projects are optimized for C2. There is just, backend code, which is built more or less in domain, not driven, there's like business first. So we have lots of business concepts without too much low-level optimization. So I wouldn't be concerned in enterprise with C2 optimization. And we have
absolutely.
Regular, yeah. Mm-hmm.
Absolutely. On the code that normal, like if you think of a normal Java developer, like very often they write some business logic, and performance considerations are, if not on the radar, they just do like a quick check that there are no like obvious like pitfalls, like exponential complexity somewhere, or like loading database entities in the loop, right? But normally we don't spend time optimizing the every last bit. So on code like that, very often GraalVM shows performance boost over C2, and it depends on the code path and the workloads and everything. But it could be this and that. There are a couple of large companies that openly say that they use GraalVM Community Edition technology. Namely, one, of course, is Twitter, and they say that they get out of the box something like 10% performance improvement, like throughput improvement, and they can tune it further by using various like command line options to tune it for their workloads, right? So and then they get something like 8% more on that. And then recently we published a blog post based on the session by a Facebook engineer where they say that they're running their Spark workloads, the big data workloads, and they also get something like 10% on GraalVM Community Edition. And then but it varies. It could be larger, it could be slower. There are the difference is GraalVM compiler comes with a very, very good top tier high level optimizations. Mm-hmm. Right, so we have excellent inlining, we have excellent partial escape analysis, we have excellent polymorphic inlining. Those are the optimizations that trigger very early, right? And then if your code is kind of sort of abstract, if it uses abstractions, if you create objects, if you use the collections library, right? If you have interfaces, and through those interfaces you call any system of a plugins or anything like this, right? then you will hit those optimizations, and then GraalVM will have a chance to shine.
What actually means that what you said right now, this is how application servers are implemented, right? Application servers and microservice runtimes. So if you take a look at an application server internally, so application servers have plugins, they have interfaces, they have to be abstract because they are comprising plugins. So what it means is it will be actually a good case just to start an application server on Graal and an OpenJDK and see what happens, and even run it. You can just because this will be a very good test, regardless what the developer is doing. The code hits the application server first, the entire execution pipeline, one point of time, and lands in your code.
Yes. So then that would be a good case. And there is definitely, if you're interested in getting some performance boost, you should run it. You should try it. It's a compatible. You can just download, switch the path to a different Java, right? Java binary, and run it and see what happens.
Yeah. Regarding installation, what I remember at the beginning, it was like drop-in replacement. So you could actually replace some binaries from your OpenJDK project, and it became GraalVM. And today, maybe you can do this as well, or just download the entire GraalVM, right?
It is easier to download just entire GraalVM because, well, we don't publish individual binaries.
No, but you remember that at the beginning, if you have GraalVM, you could download, I don't know, a parts, and you could patch the existing one. This was the official installation at the very beginning of GraalVM, and now you can just download the entire thing, right? So which.
Yes. At the beginning, what you are referring at the beginning is before GraalVM started trying to become this industrial project, because before the first initial releases, I think, right? So yeah, this is I would like, it is possible, right? It is possible probably if you figure out where to put the correct jar files and where to put the libraries, and if you have the correct version. So the hotspot and the compiler integrate using JVM CI, which is the Java Virtual Machine Compiler interface, which is the interface to plug in third-party compilers. It was added in Java 9 with the JEP 243, if I'm not mistaken. So it's an officially part of OpenJDK. And if the versions of every component kind of match, then you can get similar setup.
Okay.
So if you know what you're doing, you can maybe just build the open source components yourself, only the particular jars or something, and patch it into your OpenJDK distribution.
For me, it was an interesting fact, because what it meant to me at the beginning, that my class libraries remain absolutely compatible, because only the binaries are different, but my bytecode, the Java class libraries, I can pick from OpenJDK. So it is because, at the beginning, as GraalVM was announced, for me, it was not clear whether is this complete new implementation of everything, like Apache Harmony or whatever, or just the runtime. And with that, at the beginning, where I said, okay, I can just replace the binaries and everything remains the same, it meant I'm using now OpenJDK, I don't know what was in the beginning, 11 probably, or 10. Maybe it started with 10, I think. And the GraalVM just now replaced the hotspot compiler.
Yeah.
So for me, it was a clearer, because if you download everything, you don't know what's inside. So to clarify that, the GraalVM is just the compiler, and all the class libraries are still OpenJDK.
Yes, and this is currently still the same, right? So when we build the thing, our distributions, we take an OpenJDK builds, right? So for example, if you build GraalVM based on JDK 11 for the community edition, we take OpenJDK from JDK updates 11 project. We backport the latest JVM CI into that because the compiler needs the latest JVM CI because they evolve together. And then we build on top of that. We put in the compiler. We enable the compiler using the normal hotspot mechanism for enabling JVM CI compiler. If you do the print flag finals, you will even see that there is the use JVM CI compiler is used somewhere. So this is the same thing. The class library is the same. What is a little bit different is that the compiler is different, and then there are also the GraalVM related jar files are on the class path automatically.
Important, and I have to interrupt you once again. This Java C compiler, I guess, is identical, right? What you refer to the compiler is the hotspot compiler, right?
Yeah,
yeah,
absolutely.
it was also because you say you have to be careful if you tell the Java developer that the compiler is different. They may
yes.
think this is not like the Java C. Or do you remember back then the javac compiler from IBM, which was a very fast. Yeah, there was a native compiler which compiled Java to bytecode, which was very fast but not always compatible. Right? You remember that?
This is very interesting. The way you phrase it is very interesting. You know how people say that first you need to be correct, right, and only then you can be fast. Right? Mm-hmm. So if you're sometimes incompatible, that means that you're just not the thing that you're trying to claim you are. But yes, there were jikes. There were a number, like actually, like the whole sort of the zoo, if I may call it that way, a zoo of like the collection, the community of the JVM implementations is kind of very, very large. There are a few research JVMs. There are a few kind of tweaks on OpenJDK, right? There was this DC VM project that was capable of class reloading to a certain extent. I think there are a lot of them, right?
I'm reading now the Wikipedia, and the 2010 the javac is no more there. So there's no more actively developed. And the cool story is in 2004, the javac compiler was able to partially support Java 5, so it was able to compile some parts of Java 5, which was interesting. Right?
It was ahead of its time.
Yeah.
Right. So yes, when we talk compiler, when we say compiler, this is specifically the optimizing compiler, the top tier compiler, right? Yeah. The most important one, because even when you run your application, so first you compile it with Java C, which is a very sort of like, it's not a very sophisticated compiler. It like takes your source code and then like translates that into bytecode. But it is a compiler
in Java, right? The Java C compiler is even written in Java, as I remember.
Yes, Java C is written in Java. It is interesting. We can build a Java C compiler into the native image of the Java C compiler, and then it starts very fast if you want to compile a few classes. And there are some challenges with that approach. We may probably get to that. Some challenges with the annotation processors, which are inherently dynamic, and they just get into use at the runtime of Java C compiler. So yeah, but if you don't want to use annotation processors, you can compile that into native image, and then your compiler will be very snappy. Mm-hmm. But okay, back to the GraalVM distributions, right? So, and performance impact. You can try that. You can get performance differences. Many people do that. Many people use that. If your application is, so you said the application servers probably can have some benefits. Yes, probably. Also, if you are just running a small microservice, you have to understand that the technology stack before it hits your code. Mm-hmm. Say if you're benchmarking Hello World, right? The stack before it hits your code is optimized for C2. There's probably Netty, which will use the native memory for the queues and like the ePOL techniques and everything, right? So there's quite a bit of native code. There will be like a very thin layer of your application framework, which would naturally, if you just use a one controller, right? You don't even get like any splitting of the code path, because you just go into that one URL. So you have to understand that the impact of compiling and optimizing your code better will probably not be visible. So it's like it's other factors at play. So for the best results, you want to actually try it on your sort of production or relevant workloads to see whether it brings you impact or not. Mm-hmm. And as I said, there are like high level optimizations which are really, really good. And then there are probably some space left for optimizing kind of lower level things. Right?
So what we learned so far is that GraalVM is compatible with OpenJDK license-wise, class-wise, class library-wise, they're the same classes. And the main benefit is a better or smarter C2 compiler, right? This is the performance. So it means I could actually always use GraalVM. So there are no downsides.
Oh, absolutely.
This is where I'm going with it. This is the long story short, because, big enterprises are concerned with compatibility, licensing. They say, oh, GraalVM comes from Oracle, a little bit dangerous. So then what you learned right now, the same license, the same class files, but better native compilation, I say it this way. Not the Java C, rather than, advanced internal bytecode to native code compilation.
Yes. Better JIT compilation. better
JIT compilation. This is the term,
right?
Because I already had a talk with Sean, and for me the compilation is confusing because there are two kinds of compilation: source code to bytecode and bytecode to native code, and we should use two terms, right? So we have JIT compilation and source compilation, maybe.
Yes, and there are also like a few JIT compilations that happen at runtime, right? So there is this first the fast compiler that produces like decent code, and then
okay, go ahead. So now let's cover all the compilations from javac to native code with GraalVM. So
right. Okay. You're putting me on the spot like that, but okay.
Of course, you have a red mic, which is glowing. So
tier zero is just the interpreter. So you don't actually compile your code, and you just like, so the JVM looks at your instructions in the bytecode form and executes them. Tier 1 is what we call the C1 compiler without any profiling. So it looks at the bytecode, it compiles it fairly fast. And then tier 2 is C1 compiler with minimal profiling. So it looks at the method counters and the loop counters, the back edges in the loops, right? So it just gets the frequencies of code execution and whatnot. And then tier 3 is the C1 with the full profiling. So it gets as much information as it can, and of course while executing the previous tiers, right? And then it compiles with C1. And then tier 4 is in the OpenJDK builds, that would be the C2 compiler, and it always uses the full profile that it has available. And in GraalVM, that will be the GraalVM compiler. So there are levels. There are the tiered JIT compilation that happens.
JIT compilation. And before we have the source compilation, the javac compilation doesn't matter here because it's outside of JVM.
javac compilation doesn't matter. Like, so you can use GraalVM and you can use libraries from Maven Central, which were compiled by some other javac, or maybe Java Eclipse, this Eclipse compiler for Java, or like any like you can have like the bytecode that you generate with ASM, or that the classes are generated at runtime, or like like the JVM works on the bytecode level.
Yeah, exactly. Right? So you can use Maven, and just with a little bit of effort, you can copy the target folder to GraalVM, and then it will be happy with the bytecode. And all the compilations, what you mentioned now, is bytecode to native. Exactly. Okay.
Yes, cool. Absolutely. Right. So that's why like it also works the same way for other JVM languages, right? So like Scala doesn't produce your Java source code, but like it goes directly to bytecode, and GraalVM is very happy at executing that. Kotlin and Groovy and whatnot, right? So, and then the GraalVM also has the Enterprise Edition, which is the product by Oracle, which is proprietary distribution of GraalVM, which is currently part of Java SC subscription. So if you use Oracle JDK, we are via the Java SC subscription, you should be able to use GraalVM Enterprise Edition. It's free in Oracle Cloud. There are a number of ways to get it or try it and everything.
What it means is free in Oracle Cloud. It means if I would run a Docker application on any Oracle Cloud service, I could use GraalVM Enterprise Edition. It works like that, or
Yes, I think so. I think so. So because, like on the Oracle Cloud, you should be able to run GraalVM Enterprise Edition and the license.
If you find a link, send me the link to the show notes. This is, of course, this can change all the licensing, but it's interesting.
Yeah. Yeah, and so it's the same as Oracle JDK, so it's free for evaluation and development. So if you develop your applications for GraalVM, then you can use it. And GraalVM Enterprise Edition differentiates, like in the first head, it differentiates on performance. So the just-in-time compiler is better. It is more sophisticated. It has been more engineering power and research put into that, like a lot more work into that. So it is smarter. It is better. So it produces more optimized code, and it is so on average, it's something like 30% faster than C2.
Okay.
Average, so here it's very kind of sort of hand-weighted term. This is something that I would expect. If you would give me an application, this is something that I would expect, for example, right? Okay. But of course, it also varies based on workloads and everything. Okay. If the code patterns kind of are nice for the GraalVM compiler, or maybe not nice for C2, then the difference could be like several times faster, right? And then if C2 is great at optimizing a particular bit of code, then they could be sort of equalish with the Enterprise Edition. But the Enterprise Edition is supposed to be universally better. And if it's not faster than your workload in C2, the team would consider that a bug. You can submit that, and we will make it faster.
That's interesting. So you get decent performance in Community Edition, and we can optionally pay more and expect better performance. If it's not faster, we can file a bug.
Yeah, absolutely. Right. So that is how it works.
It would be a cool business model for me, right? I can say, okay, I make your code faster. You could pay me something, and it'd be more than this what a client would pay for Oracle, And if it's not faster, I will file a bug at Oracle, and this will be my new business model as a consultant, and I'm on vacations. So I will just redirect all the requests to Oracle Labs and just be in between. This would be like a facade pattern,
Yeah. if you find that bit of arbitrage there, then absolutely you can.
With machine learning on Oracle Cloud, of course. So I will find this arbitrage on with machine learning on Oracle Cloud, where I could use GraalVM and I will find it faster.
Yeah. That is in a nutshell. That is the perfect one line sort of description of how Java developers can benefit from GraalVM immediately, right now, and without a lot of sweat. Right?
Yeah.
Just use it as your JDK. It is compatible. It can run your code faster, and that's it. Right?
Yeah, and this is not that widely known. What surprised me, many people know GraalVM just because of the native compilation, which cover later. So, and the first part is if I tell this, that they're surprised that actually the GraalVM is also a very decent OpenJDK, basically OpenJDK on steroids, right? So this is not all. So there are some interesting parts in the JVM part, and this is, you already mentioned that, polyglot programming. And the interesting part is that you can actually load supported languages, which is R, Ruby, Python, WebAssembly, I think, JavaScript, and they can communicate even with each other. So it seems like the GraalVM comes with a metadata protocol. So all the JVM languages, or not JVM, sorry, all the third-party languages are sharing, and the languages are executed on actually the JVM. So that there is no security risk, because it's not like the Python is running in Python interpreter. It's actually running on the JVM. And I think the framework is called Truffle, right?
Yes. So GraalVM supports a number of other languages which are non-JVM. So JVM languages work natively through the bytecode, right? Very simple, and it works through the same machinery as in OpenJDK. And support for other languages is implemented a little bit differently. So there is a framework called Truffle for implementing languages on top of the GraalVM. And what it gives you the API to create an interpreter for your language, right? So you have to parse your language, like program, and then create an abstract syntax tree of that program using the Truffle API. So essentially what you're writing an interpreter for the language. You're fixing the semantics of the language that you're going to run. You use Java for that, which is very cool, right? So so your language implementation consists of there are like a number of node classes that represents different nodes in the AST. For example, there will be like a plus node, and the plus node will be like to have two children, two like expressions, two values that it needs to kind of add together, and there will be a method that describes how this addition should happen, right? Whether it's like I don't know, you can convert operands to strings and then add them together, or you can convert them to like numbers, or if they're not numbers, you can throw exceptions and whatnot. So you describe the semantics of the language. And then GraalVM at runtime. So, and you describe that as a Java application, right? So it's your jar file. You make it available within GraalVM through the certain like mechanism. And then when you writing your Java application, what you can do, you can create a context for particular languages that are available for you, and then load and evaluate code in those languages within that context. And what it means that program will be parsed, the AST using the Truffle objects will be created for you, and then it will start executing. So, and as this is an interpreter, this is sort of very simple. You run through the tree and you evaluate every node as you see that. Right, so the same way as like a Java interpreter interprets bytecode, they kind of you just go and whatever you see, you execute. You say like, oh, this node execute method next node, execute method, next node, execute method. But then at runtime, like a very fascinating things happen. So first, your interpreter gets specialized and partially evaluated together with your program.
Mm-hmm.
And this is a very interesting technique. It's called also the Futamura projections, right? How you can sort of fuse the application and the interpreter running that into one call, like into one entity. So you sort of can think about that as inlining your application that you're running into the interpreter.
Yeah. Just to recap, as I'm an application developer, what you are saying is you give me a framework where I can define my own language or my own parser, which parses my own language. So I could create whatever language I like, which is interpreted by Truffle or GraalVM by your, however you call it. And now the cool thing happens. Because the framework is written in Java and compiled to bytecode, it is optimized as any other bytecode because it's a part of Java, right?
Well, so first it will undergo this partial evaluation thing.
Okay.
Right. So the framework of like your language implementation, of course, is Java. So it is compiled to bytecode and it can run and it can get JIT compiled. But that brings very little benefit usually because the interpreter is in itself is like a small part of your thing, and then your application is a like a second very large part of input to like your application like entity, right? So what GraalVM does at the Truffle level, it kind of sort of fuses them together. It partially evaluates, like it specializes the interpreter to execute this particular program.
Okay.
Right, and like automatically, and then it creates the
bytecode interpreter you meant, right? Bytecode interpreter? No, the Truffle interpreter.
Yeah, the Truffle interpreter. Yes, and then it doesn't compile that to bytecode intermediate representation, right? But it creates the GraalVM compiler graphs like internal representation out of this partial evaluated like program, and then it compiles that to machine code.
So to understanding is I have my tree which comes from my language, and GraalVM takes the tree and transforms the tree to something which is more understandable by GraalVM or more optimized for further compilations, right? Like a translator.
No, not exactly, but like in a nutshell. So think about it. You have an interpreter that can run any type of programs, and like for example, your language is adding two objects together.
Yeah.
Right. So you will have a node, and then it can add like A and B, left and right sides.
Yeah.
Right. And then you start running your application, and your application only gives you numbers. Right. For example.
Yeah.
So what GraalVM can do, it can sort of transform your interpreter at runtime, the representation of the interpreter, into the version that only accepts numbers. And then if you pass anything else, it just enters sort of the optimization routine there. So if
this is similar what NAS1 did. Remember NAS1? JavaScript language, they assumed like the type is int, and if something else will come, they will reevaluate whatever came, right?
Yes. Sort of like that. But like so that happens automatically, and that doesn't just happen for the types of the types of your data that comes in, right? But what it can do, it can sort of transform the interpreter that you're having and kind of specialize that for the particular application.
Yeah, I got you. The problem is in my language, it is too abstract, and GraalVM can interpret that and then sees what actually in there, and it has heuristics and say, okay, in this particular case, I'm assuming it's always the case, and then it can run faster, right?
Yes. And then it passes that to the JIT compiler, and the JIT compiler can also compile kind of sort of the mix of your application and the mix of your language interpreter, the language semantics, and the application that you're running. And that's like this JIT compilation comes to like it is given to you for free because you don't actually write the compiler, you don't actually write the VM, you just write an interpreter for your language. But the end result is fascinatingly has very decent performance compared to the runtimes where this compilation has been done like manually created and supported for a number of years.
And the interesting part is that the GraalVM team came already with several interpreters which are ready to use.
Yeah.
And
yes.
Yeah, and this is crazy because you get the recent JavaScript interpreter, for instance.
Yes, our JavaScript is compatible with ECMAScript 21 enabled by default, right?
Which is crazy. Really, no kidding, because it's cutting edge, actually.
It is. Yeah. I think we have implemented some proposals from the 2022, or we are like on track with that. So we are as compatible with the JavaScript standards as, like, say, normal Node distribution and V8.
Exactly. Per accident, I ran 1 year all my Node builds on GraalVM, and in one time I forgot. I had to upgrade something, and I say, why it's Graal? And then I forgot, actually. So this was a funny experiment. All the builds, and I didn't recognize that this was by accident. And then no,
yes,
this is really compatible. And so, what is the next language?
Right. So JavaScript, like, just to address that, in the past, yes, we had Node.js distribution at part of the base builds, right? And now it's just a separate component that you install. So now if you download just the GraalVM distribution, you don't get Node by default, but you have to install that as a sort of installable component. The next distribution is, for example, Ruby. Ruby. Ruby is compatible. I think we are targeting 2.7 currently, compatibility. The interesting bit there is that we also run not just Ruby code, but also we run the native extensions through the same mechanism. So we have the LLVM bitcode interpreter. So when your Ruby code calls into like a C function for like some, I don't know, JSON parsing or something, we run that C also on GraalVM in the same way. Right, so there is an interpreter, and it gets specialized, and it gets compiled. The cool bit there is, like what you said, that you can run different languages on the same JVM, right? With the coolest bit is that not just we can run them, but because they all look like this abstract syntax tree interpreters for us, like from the runtime point of view, we can also compile across the language barrier. So we can you can have a line of Ruby and line of C code that call each other, and there is no barrier between that. We can, for example, inline the C code into your Ruby code.
So what you mean is even crazier. I could actually have, let's say, more realistically, JavaScript and Python is also supported. And Python is very popular in cloud, for instance. So JavaScript and Python. So GraalVM will combine the both trees and optimize them together, right?
Yes.
So it will look like, for GraalVM, like one language. It doesn't matter because it only sees the interpreter, the tree, and this is the JavaScript and Python, and it will find, optimization, cross-language optimizations, right?
Yes, so it can, for example, inline the Python into JavaScript. So and there will be no like method calls or anything like that there.
And by the way, I use that with Java because this was the reasons why I use GraalVM a lot. There are lots of useful JavaScript libraries. What I remember was this was Mustache and Handlebars, like the templating. And we use that a lot for, let's say, invoice generation, like something like replacement of velocity. And why we do this, because the web designers already knew Mustache, so they created for us the templates. So we just used the templates. This was actually the business case. And so in my particular case, Java called JavaScript, and I loaded to the JavaScript runtime the one-to-one, the ready-to-use JavaScript library from whenever I just downloaded that, Mustache or I think I use Mustache or Handlebars. Both are very similar, and then it just run very quickly. And so this is what I did the most with GraalVM, and then became curious because in one project we had some Python people who wanted to implement some business logic in Python because they knew that. So we called from Java Python, and this was the more boring enterprise cases where we used the coexistence of polyglot, and this worked surprisingly well.
But it's also more exciting from the developer point of view, right? Because with JavaScript we had Nashorn, we had Rhino, it's not something that you like. It is groundbreaking, and GraalVM takes a very different approach to those.
And GraalVM is Nashorn compatible, or at least compatible to call it. That you can use the same API, right? The scripting API.
You can use the script engine API, though I would recommend to use the GraalVM polyglot API. because there was a better options for configuration, like security and whatnot. But there is also a NASFRN compatibility mode, which makes JavaScript behave more like NASFRN, which is where it differs from how, for example, V8 does things. But there is certainly, like, you can migrate to GraalVM, the GraalVM's JavaScript implementation. It's fairly smooth migration. But Python is more interesting probably because there was Jython, but that was like, I don't think I've heard many good words about Jython.
I remember in 1997, developers came to me and asked me, why are you using Java and not Jython? And I have to justify, because I don't need Jython. So this is all, if I hear Jython, it's always, I remember the project where everyone asked me why I'm not using Jython. It's like, because I'm using Java. At one point, I just stopped argumenting.
Yes. So but GraalVM's Python, right? Our Python implementation is modern Python compatible. It runs modern Python. We run native extensions through this LLVM pipeline. There are some corner cases for particular native extensions because, Python foreign function interface is not as documented and well specified as, say, JNI. Right, so there are extensions could do various. They can depend on the implementation details of Python runtime, right? So if you want to switch the Python runtime and run the same code, then it's very hard, right? So we are fixing those cases if you're running a particular Python module, right? Python package, and then it doesn't work for some reason. Please raise an issue on GitHub. We are always interested in learning what parts of the ecosystem you're running and using, and we would like to make that work, right? Even if it's not fast at first, we would like to actually run it. So, and then but you can run them together. You can run all three of them together in the same runtime, right? And then for JavaScript, I know many people use that for the server-side rendering of React apps, because then they don't have to sort of in another Node.js process just to render HTMLs.
And Node.js in CI/CD is terrible. So it is way better, to use your everything in one GraalVM.
Yeah, well, if your application is in Java, right? You don't want two runtimes running.
Yeah, exactly.
So, and then you have Python, you have Ruby, we have WebAssembly, which mostly kind of sort of helps JavaScript because the JavaScript ecosystem now gets enriched and enhanced with the WebAssembly modules. We
Can
have
you actually compile Java to WebAssembly with GraalVM?
No. So we will cover that maybe a bit about around native image, right? But in short, no.
Okay.
So, and I don't know particularly that much about WebAssembly. But I think the current spec doesn't offer, for example, a GC implementation, right? So you have to bring your runtime with you, which makes it a little bit awkward as well.
Okay.
But yes, so WebAssembly is very good for native languages which don't have the runtime. So that's why you have C, C++, Rust. You also can have runtimes, there are a number of examples like TinyGo, but they bring their own runtime to WebAssembly, I think. But this is to the extent of my knowledge about WebAssembly. We do run WebAssembly in the sense that we can, if you have a WebAssembly program, we can run it on GraalVM, but we don't compile that to WebAssembly.
And what I saw, you're also implementing the VASI interface, which is like a POSIX interface, so the assembly can call actually via VASI GraalVM, right? This is what I just briefly saw.
Yes, I know that the VASI is a WebAssembly system interface, which is sort of the interface that is targeted for server-side WebAssembly runtimes. So your WebAssembly program can actually do something meaningful besides just warming up the universe.
Exactly.
Right. So, and as much as that is a part of the spec, I think we are implementing that.
That's what I also saw.
We need to be compatible. I don't think we're actually calling GraalVM through that, but
or the operating system. I mean, you will have to call a file or whatever. So you will have to provide the interface to the operating system somehow, whether through Graal or not.
Yes. So most probably the implementation of those system calls are based on the Java implementation.
Okay.
So, which is kind of like if you think about
this is what I meant. This is already confused because in Java implementation I meant Graal because everything now is Graal for me, but it's just Java. It's plain Java. Maybe plain file or whatever they're doing. It's just through Java libraries. This is what I meant.
Yes. Yeah. So, like, just to give you an example of why this having an interpreter approach is so significant, right? In the like maintenance burden like reduction. At some point of time, JavaScript added those big numbers, like sort of a big integer, similar to big integer thing, where you can have a very long number, and that would be a literal, right? So, like, it's very hard to like kind of build that into your runtime system when you're already building the compiler manually and everything. For us, it was very simple. We added a new node type that was like a big number, right? And the implementation of that reuses the big integer facilities, right? With the like implement that big number using the big integer, and it was a very small commit or a series of commits.
Okay.
Right? So that's why having the interpreter is so powerful, because you can keep up with the changes fairly trivially, and then so you can run multiple languages together. What you also can do, the tooling works on all the languages the same, because all the languages are naturally like just trees, right? So if you have some tool like a debugger that works on the trees, then well, there is no reason why it cannot support all the languages. There could be that minimal interventions required, like for example, you can mark the some nodes as being like an expressions that can be evaluated, or like the value of that can be highlighted in the debugger. But those are like small trivial sort of changes, right? And then, for example, you can use the GraalVM. And
so what you're saying now that because everything is a tree and is understood by GraalVM, all the languages supported by GraalVM can be debugged using standard debugging Java tools.
Yeah.
Yeah.
It's not the standard debugging Java tools, but like there's a debugger implementation. I think it's based on the Chromium Inspector protocol currently. But like, yes, you can debug them using a single debugger.
Single debugger which ships with GraalVM.
Debugger protocol ships with GraalVM. If you enable that, it will give you an URL, and you open that in Chrome, and then the Chrome debugger for JavaScript will also allow you to debug other languages.
Which is even better, because you don't need IDE. I mean,
yeah, you don't need an IDE for that. Yeah. You can debug in the browser like that, which is very, very interesting. Or the profiler, right? Because all the languages are just naturally trees. You can instrument them in the same way and like take the sampling or trace their execution. And or there is an instrumentation library where you can instrument your application like using like snippets and registering on events, various things, right? It all works the same for all languages as well. So you can, for example, run your Ruby application and have your instrumentation code being in JavaScript. Which is so like there are very
and even you can profile cross-language calls, I assume, right? So if Ruby calls JavaScript, you have and even debug step by step. You can call from Java over Ruby to JavaScript. For instance, you can cross-step the entire call stack, right?
Yes. Well, Java is a little bit different when you run it through bytecode. So because like that will, but like if you talk about the GraalVM languages, then absolutely. Oh, also we have almost forgot. Silly me. There is a Java and Truffle implementation.
Right? So stop that. I on purpose try to know not to mention Espresso right now. But so we have JavaScript, Ruby, Python, R, right?
R. We have R. Definitely. We have WebAssembly. There are a number of community languages that are also implemented. Right. So there is a.
But this ships with GraalVM built by the GraalVM team. So you get more or less not official support, maybe official support if you buy the enterprise support, but it is officially developed together with GraalVM, which is appealing for me.
Yes. So like there are different kind of statuses on that. Some of the components are experimental, some of them are supported. So you have to check with the tables and with the docs. But you get the maintenance, right? So like let's not call it support because that is a strong word, but you get the maintenance of the languages by the GraalVM team. Right, but it doesn't like the community languages are not like worse in a sense. Like they are very good, stable, maintained implementations. They're installed, for example, into like you can take GraalVM distribution and install, for example, this Smalltalk Truffle Squeak implementation into that using the normal GraalVM's this updater utility, just the same way as you would install any other language. It's maintained by a different team.
Okay.
And I know that other people develop languages, and some of them are in-house, some of them are publicly available, which is very, very cool to see, because you can very easily kind of see in action this promise that, oh, you can implement your language in GraalVM and it will be fast, right?
Yeah.
And like the effort required for that will be much smaller than if you would start implementing everything by hand. There was this
fast is interesting. What interests me is even more appealing, the seamless integration. This is what I like the most. Because as I started, with the JavaScript integration, I was not that interested in speed. I was more interested that it actually works. And because, if I generated something, it was like a report, so no one cared about the performance. So it was always, second thing, but it's actually fast, what is important for my project right now. But that it actually is so seamless. This is genius, because you can combine all the programming languages, and speed on top of that is, of course, even more interesting. But the seamless integration, which is what's interesting. Okay, and now about espresso. So now we get how you call it, meta circular, right? So
yes,
you can now run Java on Truffle, which runs on GraalVM and uses OpenJDK Java. So Java runs on Java, right?
Yes.
So and what means is, at one point of time, the GraalVM team has said, okay, there's nothing else to do, and they try, to run Java on Java just for fun, right? Too much vacations.
No.
What is the use case? Someone asked me, what is the use case?
Yes, this is very interesting. So you have to understand that GraalVM team at Oracle Labs is a research and development institution within Oracle, right? So people do academic work. People actually push the boundaries of what we know about computer science, how to run like languages and runtimes. This is the bleeding edge research in programming languages and so on. There are other teams at Oracle Labs which do other things, like there is machine learning and graph databases and some other projects. But like I'm talking about GraalVM, right? This is about runtimes, about languages. We do academic work at the absolute like limits of what we currently know about how to do languages. And GraalVM is a very interesting target for that, because it's very easy to create new languages. It's also very easy to create and explore new tooling, and it's very easy to create and explore new optimizations, because, well, everything is in Java. Everything is kind of sort of hackable very easily. Well, to a certain degree of easiness, right? You still have to have the expertise to some level, but it's much easier than some other projects, for example. And yeah, I think it's the Java on Truffle implementation started as the internship project.
Okay.
Right, and then there was an intern, and we have a number of internship projects every year, which is very, very good chance if you're interested in compilers or languages. So, and then it took shape, and then it was a very interesting approach. So because normally we have the sort of the language interpreter at the source code interpreter. So Java bytecode, like Java on Truffle, runs on the bytecode level, right? As well as everything in the Java ecosystem. So it's a bytecode interpreter, which is a little bit different, and it allows for different optimizations. So we explored that approach, and then
wait a sec. What does it mean that that is not an interpreter? So the espresso is
it's not like a source code tree interpreter. So it doesn't take the Java source code.
Okay, it's different to Python, Ruby, and the others, right?
Yes, it's similar to the LLVM bitcode interpreter, because LLVM bitcode is also like sort of bytecode-like language, but it's not it doesn't take Java source code.
Because what I understood is in JavaScript, so there is an interpreter for JavaScript which is written in Truffle, and then GraalVM takes that, which would be interesting actually, to use a source code interpreter for Java, right? Would be also possible actually.
It would be also possible. It's also like, so when you say Java, right? This is
Java source.
This is in like Java in general, right? It's a little bit complex subject, right? Because you cannot just call something Java, right? Because like Java means certain things. There are certain APIs that have to be present. There are certain tests and verification processes that you have to pass to call something a Java implementation, right? There is you cannot just make something that runs, for example, like Java source code, right?
You're right. Because if you would use the Java source code interpreter, you couldn't load bytecode libraries then, right? In ClassPath, you could only run, the Java source code, which is available to GraalVM. But if you would try to call jars, it wouldn't work then. This would be the problem, right?
Yeah. Yes, that would be the that would be the problem.
A significant problem.
Yes, but also you have to implement the calls to native, right? You have to implement GNI. You have to implement various runtime components like the verifier, the class file verifier, because otherwise you cannot be Java implement. You can sort of run some Java programs, but you cannot be a Java implementation. Right? So to be a Java implementation, you have to be actually compatible and pass the tests, and so there is a whole this kind of sort of
like a bean shell. You are aware of bean shell? I think this was like the Java source code script language. Remember that project back then?
I think I remember the name. I think yes. I think it didn't fly very much.
It was actually fairly popular in some enterprise project. They store Java source code in databases and executed it on demand, like for scripting purposes. So, but
yes, yeah. But remind me about that later. There is
back to you.
Java.
I have to interrupt you because there are too many ideas. But the Java on Truffle is compiled to bytecode. And then
it's not.
It's not.
Java is compiled to the bytecode, and then it runs on Java on Truffle.
Yeah, exactly.
And then at runtime, it gets JIT compiled without going to bytecode again.
Yeah, so the Truffle uses the bytecode as the tree, right?
Yes, for building the tree, right?
Yeah.
So yes, and then it can run. So that kind of elevates Java, if you allow me this expression, to the status of other GraalVM languages.
Yeah.
Right. So the tooling that works for the other languages works now the same way for Java when you run the Java.
So now finally I can debug my Java in Chrome browser.
Yes. Yes, absolutely. And you can profile that using our profilers, and you can run it through our special integration in GraalVM.
Yeah.
Right. So, but you also the thing is, you can run your Java application within another Java application, right? So that's what, you can run your Java implementation in your Java application, and you can actually run this several layers. So Java on Truffle can run Java on Truffle, that can run Java on Truffle, that will take 15 minutes to hello world.
What means means we could actually have something like very efficient AWS Lambda implementation, right?
For Java, yeah, absolutely, right. You can have sort of a serverless environment where you have the runtime, the OpenJDK GraalVM based runtime, and then the request throws you some bytecode, and you say let me execute this.
Exactly.
And of course, Truffle comes with the context abstraction, comes with all various checks and limits, so you can say I would like this code to run at most 1 second, and there's this much memory that you can use, and this much CPU, and they're somehow enforced. So there is a sort of a sandbox for the Truffle that you can use to kind of isolate.
So almost Docker, right? In a Truffle already.
Yes,
like a secret to namespaces. What they're talking is this. For me, I try to map the ideas. It's like a Docker ideas implemented into Java.
Yes. So there is a sandbox that isolate the level of isolation that works for the Truffle languages, right? So, and you can run your Java on Java, and besides that being a very kind of interesting goal in itself, that is also a very cool. It opens some cool use cases. For example, you can run your application fully on, say, Java 11 or Java 8, and you can run certain libraries using Java on Truffle with Java 11. If you want to, right? So you have that degree of separation, or some benefits are becoming apparent for when we think about the native image technology, right? Because native image can take your Java application and compile that ahead of time to the binary.
What I suggested here, because we are 1 hour, we are talking about 1 hour. Then in another episode, we will just cover native image. I think there's enough to talk, because otherwise we will have 2 hours. I would invite you back just to talk about native image and all optimizations and what to do, because you can do really cool things like command line applications, shipping custom runtimes and stuff like that just with GraalVM. And this will be a complete different topic, I would say. But back to the Java source code. So what appears to me, the work started by a student, and then you saw that and say, hey, this is more interesting than we originally thought, and then you dedicated some more resources to make a product out of that, right? Or
we originally thought that this is very interesting.
Okay.
But they were
okay.
It's still, the work has started as an internship project with the degree of flexibility of freedom for the students implementing that, right? And then the initial implementation was in a fairly good shape. It validated some assumptions about performance, for example, and then we took it to the next level, right? And this year in January, I think we had the initial release of Java on Truffle.
It's called Espresso, right?
The code name is Espresso. The official name is Java on Truffle.
Okay.
And it has a few, so currently it is not fast, right? It's not fast enough yet, right? It is decently fast. It's not horribly slow, right? But there are a number of, you compare that to Hotspot, which is a very fast runtime, right? It's really not easy. And people very often say oh, Graal and GraalVM team, they talk about performance and they kind of sort of bash on Hotspot or C2 or whatnot, right? That is not true, right? There is GraalVM distributions are based on OpenJDK, right? So we sort of depend on that project. There is just utter respect for the teams that are doing that, right? And when they say just something is faster, it doesn't mean that the counterpart is slow, right? It just means it's slower, but it's still
and there are different, I would know, fastness, right? Options, because the native image is actually currently a little bit slower than the JVM execution, but it starts faster. So what can happen here is that, for instance, you can say, okay, this Espresso or Java on Truffle is particularly interesting for serverless environments because it loads and starts very, very fast. But the execution time, so the execution optimization are slower, but it doesn't matter because if such a function starts and stops in 100 milliseconds, who cares? How far? I mean, there are completely different use cases. So talking just about performance is sometimes absolutely pointless, right? Because
yes. So performance is something that you have your SLA, right? You have your the performance is relative, right? So
exactly.
But so just to clarify, Java Truffle performance profile will be similar to Hotspot, right? Will be similar to this JIT compilation. So it will start, it will load the classes, it does everything that the JVM needs to do: verify classes, load classes, find them, create the class loader hierarchies, load them, and then it specializes itself and then compiles at runtime. So there is a JIT compilation step, and then it makes it faster. But in both cases, the startup and this runtime throughput performance are currently not comparable to even OpenJDK with C2, not even talking about GraalVM, because we just didn't get much to optimizing performance. Because we focused on correctness and working out the things. So performance is yet to come. But one cool thing about Java on Truffle, which can be used right now, is the enhanced hot swap capabilities. Because it's a new kind of sort of the structure how Java on Truffle implements things, right? This they're trees, right? It allows for easier code reloading implementations. So what we did, we implemented the Java hot swap, which is when you're running in a debug session, you can instruct your IDE to send the new bytecode to the running process, and the running process will replace that code in the running application, right? So a normal Java
hot swap, mini application server, right? Which is very exciting.
No. It's the
I mean, no kidding. You could have one running process, and hot patch, this is the infrastructure, and hot patch the business logic.
Yes, but it's not unique to Java on Truffle. So Hotspot can do that in a debug session just like that, but Hotspot is limited to patching the method bodies in a debug session, of course. So you can patch the method bodies, and Java on Truffle allows you to modify more things within the running process.
Yeah, what would be cool just to be able to reliably replace the entire thing. You say, this is my part, which is the business logic, and I would like transactionally or atomically replace the entire thing. So not single methods, rather than the entire array. This would be great use case.
Or like the classes add new methods, change signatures, right? Like and it's a little bit.
I'm thinking about a small like a function, right? So
you're thinking about the production use cases, right?
Yeah, I'm thinking about production, and you are so like the research use cases.
So currently this is more targeting the development use cases, because even like you don't normally run your production in a debug session as well. Right, but potentially you can. Like, nothing that prevents you to debug in production.
Cloud could, right? I mean, I'm thinking so cloud could do whatever they like. I would just push my bytecode, and they will reload. And what they are doing, I don't care, right?
Yes, though they potentially yes, but there are currently also not all changes are supported. So, namely, one is a sort of a large limitation is that changes to the fields are not supported yet. We're working on that, but the field changes are not yet covered, which makes it still like a limited use case. But it is already more powerful than hotspot functionality.
But you will get there. What's interested me, the possibilities and what is going to be possible. This is the exciting part, and maybe with that it would be also possible to create the WebAssembly at the end of the day, because the Java runs now inside GraalVM, maybe another internship project. It would be technically possible to learn from that and create WASM.
Well, yeah, maybe,
who knows? I mean, just because you are already running on GraalVM and GraalVM knows about WASM, and it's the same tree. I mean, technically, it should be possible to somehow, evaluate what happens there and create WASM, whatever. So this would be interesting case, right?
I think this is mixing two different projects, but it would be interesting to run for WASM. There are two use cases, and I think this is what people in general think when running on compiling to WASM. One is you want to run this in the browser.
Less interesting,
right? One is to run in the browser, and the other one is to run on the backend WASM runtimes.
And the most interesting is to run WASM in the caches. What you can run, you can run WASM on edge. This means on clouds, there is a CloudFront, for instance, or I think Fastly. I forgot the name. So you can actually run WASM code directly in the cache and provide some routing, cache validation and whatever. This is this is really interesting part.
But that is the backend.
This is the backend, and it moves almost to the front end, So this is a very front backend.
And you can very easily just put the whole GraalVM in it.
Yeah, this is what I meant. Because
what I mean is, it's not like you compile GraalVM functionality to WASM and put it into say this edge cache implementation, right? Mm-hmm. But you have a cache implementation that uses full GraalVM, and then you can.
Currently, is not that, right? Currently, you have to ship WASM.
Currently, it's not that, but it would be very interesting. And the same thing is, people very often ask us, when should we maybe release a browser based on GraalVM, so you can program front end using other languages. Okay. And in a nutshell, that would be a very interesting project, right? Taking maybe Chromium and replacing the 8 with GraalVM. Given that we did that for Node.js, we sort of potentially can do that. Yeah. There is more work. That Node.js uses only a subset of functionality that the browser uses when embeds. But it could be possible. But it's also it would be much more impactful if someone who already has a browser would do that rather than us.
And the problem is the acceptance. For instance, Google Chrome, they supported a Dart language, and they stopped to supporting that, and they just support JavaScript. Would be really hard to argue for Oracle to support such a thing regarding the community acceptance and security is the next one. Everyone would ask, what about security? And this is, but interesting for sure.
Yes, and so one interesting use case where you build in GraalVM technology is, for example, the database. The same way as you said, the caches, right? Yeah. There is a very large chunk of applications which are actually the database, and there is a one vendor of databases which is very close to GraalVM.
Yeah.
and it's been a very interesting development. So now currently, I think you have GraalVM in the Oracle database.
Yeah, and this is also interesting because you could write not yet, but you could write that stored procedures, kind of stored procedures in Java, and if the data is close, the business logic is close to the data, it is the most simple way to develop applications. So if you are okay with it, it's just really interesting. It's called this could be also moving the business logic closer to the edge and closer to the data, which with GraalVM would be a Java, for instance, or one of the GraalVM languages for me as Java developer, Java. And I don't know whether you're aware of it, but Oracle started with that. There was a project called Aurora virtual machine. It was like 1996 or 1997, and I tried with that. You could already run back then Java applications in Oracle DB, but they were slow. And now with GraalVM, it is really fast. So I'm really excited about that because I experimented with that at the beginning of Java already. I think it was JDK 1.1. So if you search for Aurora Oracle, you will find the old documentation at Oracle.
Yeah.
So perfect. What I would really like to do, invite you back and just talk about native compilation and whatever you'd like to talk, right? Because you are the evangelist, so you have enough topics. But there are so many misconceptions, and you are the perfect, guy to cover that. And because if I mention GraalVM somewhere in my projects, that my clients immediately think just about the native compilation, which is for me just a small part and interesting for some use case, but not for everything. But GraalVM is more than that. And if you like, we can cover this in one subsequent episode. So where people can find you on the internet?
Yeah, I would be absolutely honored to come and talk about native image specifically, right? I think there's very easily to cover one episode. Maybe we will have it a series even more because that is a very large and exciting topic. So I would be happy to share what I know about that. People can find me on the internet. I am on Twitter, so you can @Shalaev, and you will see me on Twitter. I'm mostly on Twitter. You can send me an email. I'm always
and Medium. So you are a blogger, right? So there is some excellent article from you.
You can. Well, if you're interested in GraalVM, you should maybe just go and check out the GraalVM Steam blog on Medium, medium.com/GraalVM, or just go and look through the website, which is graalvm.org. We try to make it kind of sort of product-like, much more, right? And like if you compare that to some other Java websites, I think we are doing a
it looks good, and you can find it looks nice, and it is really well structured. So
yes, thank you very much. Right, so there is plenty of information there from the high level overviews and how it works to getting started and everything. So this is very, very exciting, and specifically for the JIT compilation, there should be no obstacles to trying this. Maybe if you just want to try, maybe your workload isn't optimized as well as you would expect, talk to us, raise an issue. We are always open to chat. And then we'll see. And even if it speeds up your workloads for like a few percent, that is, think about that. 2% is one salary every 4 years, right? So if the last 4 years you haven't given one salary back to anyone, then you shouldn't scoff at 2%.
Okay. Then I shall file the bug in advance and hope your salary gets increased. This will be the better strategy.
No. Okay. Yeah. Of course, this is it's a joke, right? But it's also a part of the joke. As the workloads grow larger and larger and larger, any performance improvement is a good improvement.
Yeah.
So yes. And then check out the languages. Look at some blog posts on Java and Truffle. It is very exciting development. I think personally one of my favorite parts of the GraalVM project. They are all excellent, but this is really, 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 truly fascinating. So
Thank you.
Thank you very much. See you next time.